When installing surface floor outlets in commercial buildings, several code considerations must be addressed. National Electrical Code Section 314.27 requires surface-mounted receptacles installed in floors to be specifically designed for that purpose. National Electrical Code Section 314.27c mandates that floor boxes be filled with a fire-resistant material to protect the conductors. National Fire Protection Association 70, which is the National Electrical Code, Section 517.14 necessitates the installation of non-combustible floor outlet boxes in all spaces where exposed or concealed combustible material is present, unless otherwise approved by the authority having jurisdiction, (OJ). The AHA directive to stand the box upright to avoid dust is a prudent safety measure, as dust accumulation in outlets can indeed pose a fire hazard. Floor-rated outlets are specifically engineered to withstand the impact of heavy loads and pedestrian traffic, making them exceptionally well suited for commercial environments. While the National Electrical Code does not explicitly mandate floor-rated outlets for surface-mounted installations, their use is strongly recommended to enhance both durability and safety. When drilling the hole, it should be adequately sized to accommodate the outlet box along with the necessary fire-resistant material. A suitable fire-resistant material, such as mineral wool or a cement mixture, should be used to fill the void surrounding the box. The box should be installed upright, as directed by the AHA, to effectively prevent the accumulation of dust. The box should be securely fastened to the floor using appropriate fasteners suitable for the floor material. It is crucial to ensure that the outlet cover is compatible with the floor-rated outlet and provides adequate protection against dust and water ingress. Regular inspection of the outlet and its cover is essential to identify any damage or dust accumulation, with cleaning performed as needed. Proper grounding must be provided for the outlet to ensure electrical safety. In summary, the installation of surface floor outlets in commercial buildings demands meticulous planning and execution to ensure compliance with code requirements and to uphold safety standards. It is highly advisable to utilize floor-rated outlets, orient the box upright to mitigate dust accumulation, and fill the surrounding void with a fire-resistant material. Firstly, identify the relevant sections of the National Electrical Code, or NEC, that pertain to floor-mounted receptacles and floor boxes. Secondly, verify and adhere to any specific requirements or interpretations imposed by the local authority having jurisdiction, or OJ. Thirdly, assess the environment where the outlet will be installed to determine if floor-rated outlets are necessary based on traffic and potential impact loads. Fourthly, ensure that the drill hole is appropriately sized to accommodate the outlet box and the fire-resistant material. Fifthly, select a fire-resistant material that is suitable for the application and complies with relevant safety standards. Sixthly, mount the box upright as directed by the AHA to minimize dust accumulation. Seventhly, use appropriate fasteners to securely attach the box to the floor, considering the floor's material. Eighthly, choose a cover that is compatible with the floor-rated outlet and provides adequate protection against environmental factors. Ninthly, establish a regular inspection and maintenance schedule to check for damage and dust accumulation. Tenthly, ensure proper grounding of the outlet to maintain electrical safety. These steps collectively contribute to a safe and compliant installation of surface floor outlets in commercial buildings. The selection of appropriate materials is paramount in ensuring the safety and longevity of electrical installations, particularly in commercial settings. Fire-resistant materials play a critical role in preventing the spread of fire and protecting conductors from thermal damage. Mineral wool is a widely used fire-resistant material known for its excellent thermal insulation properties and its ability to withstand high temperatures without melting or burning. It is commonly used to fill voids around electrical boxes and conduits to prevent the passage of flames and smoke. Cement mix, specifically formulated for fire resistance, is another effective material for filling voids around electrical boxes. These mixes typically contain additives that enhance their fire resistance and prevent them from cracking or crumbling under high heat. Intumescent materials are designed to expand when exposed to heat, creating a barrier that seals openings and prevents the spread of fire. These materials are often used in fire-stop caulk and putty to seal penetrations in walls and floors. Fire-rated foam is a lightweight and easy-to-apply material that expands to fill gaps and cracks, providing a fire-resistant seal. It is commonly used around electrical boxes, pipes, and cables to prevent the passage of flames and smoke. When selecting fire-resistant materials, it is essential to ensure that they meet the relevant safety standards and codes, such as Underwriters Laboratories, or all classifications and National Fire Protection Association, or NFPA, requirements. Additionally, the material should be compatible with the surrounding construction materials and should not pose any health hazards to installers or occupants. To elaborate on grounding, grounding is a critical safety measure in electrical systems, designed to protect individuals from electric shock and to prevent equipment damage. It involves creating a low-resistance path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. The grounding electrode system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel with a grounding electrode conductor. The grounding electrode provides a direct connection to the earth, ensuring that the electrical system is at a stable and safe potential. Equipment grounding conductors, or EGs, are used to connect the metal enclosures of electrical equipment, such as outlets, lights, and appliances, to the grounding system. These conductors provide a path for fault current to flow back to the source in the event of a ground fault. Ground fault circuit interrupters, or GFCIs, are devices that monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. GFCIs are commonly installed in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Proper grounding is essential for ensuring the safety and reliability of electrical systems. It helps to prevent electric shock, reduce the risk of fire, and protect equipment from damage. Regular inspection and testing of the grounding system are necessary to ensure that it is functioning properly and providing adequate protection. The National Electrical Code provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the installation of grounding electrodes, and the use of GFCIs. Compliance with these requirements is essential for ensuring the safety of electrical installations. When installing electrical outlets, it is crucial to select the appropriate type of outlet for the intended use and location. Different types of outlets are designed to handle different voltages, amperages, and environmental conditions. Standard 15 amp and 20 amp receptacles are commonly used for general-purpose applications in residential and commercial buildings. These receptacles are designed to accept standard 2-prong and 3-prong plugs and are available in various configurations, including single, duplex, and quad outlets. Ground fault circuit interrupter, or GFCI, receptacles are designed to protect against electric shock by quickly interrupting the power if a ground fault is detected. These receptacles are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupter, or SI, receptacles are designed to protect against electrical fires by detecting arc faults, which are dangerous electrical discharges that can ignite flammable materials. These receptacles are required in many residential bedrooms and other areas where arc faults are likely to occur. Twist-lock receptacles are designed for heavy-duty applications where a secure and reliable connection is required. These receptacles feature a locking mechanism that prevents the plug from being accidentally disconnected. Weather-resistant receptacles are designed for outdoor use and are constructed with materials that can withstand exposure to moisture, sunlight, and other environmental factors. When selecting electrical outlets, it is important to consider the voltage, amperage, and environmental conditions of the location where the outlet will be installed. Additionally, it is essential to comply with all applicable electrical codes and regulations to ensure the safety of the installation. The proper selection and installation of electrical outlets are critical for ensuring the safe and reliable operation of electrical systems. Regular inspection and maintenance of electrical outlets are necessary to identify any damage or wear and tear and to ensure that they are functioning properly.